3.3 is on removing common factors. And I want you to learn lots of stuff this year in grade 10. But if I had to pick one thing for you to know better than everything else, it would be factoring. Why? Because for the rest of your math life, grade 11, grade 12, if you take calculus, university math, factoring just comes up over and over and over again, and you want to get really comfortable with it. So please, for the next 3, 4, 5 classes, however much we do factoring, if you can really make an effort to understand this, it'll make such a difference. Trying to get through Pre-Calculus 11 without being able to factor well is a nightmare. So what is factoring? Factoring is the opposite of multiplying polynomials. So for example, what we did last day is we did something or things like this. We answered questions like this. Actually, maybe this was 2 days ago. But you know how to multiply these sorts of things. What's 5 times 3x plus 2? Well, to do that, you do mountains, right? You would expand it or use the distributive property. And what you would get is 5 times 3x is 15x. And 5 times 2 is positive 10, so plus 10. 15x plus 10. Now, what if I actually started with this and asked you to go back the other way? Could you do that? So let's try that right now. I'm going to write it, and I'll write it on the right hand side, even though we're going to usually write on the left hand side, just so you can kind of compare it to this thing up top. If I had 24 minus 8y, what would go in the brackets and what would go out front? Now, there's different answers. Some of you might say, well, I would put a 2 out front and then a 12 here and minus 4y here, and it would work. 2 times 12 is 24, 2 times 4y is 8y, or 2 times negative 4y is negative 8y. Others of you might say, no, I wouldn't do that. I'd put a 4 here. So you'd get 4, and then you'd have 6 minus 2y. That works too. 4 times 6 is 24, 4 times negative 2y is negative 8y. And some of you might say, no, I'd put an 8 there, and then I'd have 3 minus 1y, or just y. 8 times 3 is 24. 8 times negative y is negative 8y. So these are all correct, but which one's the best? Can you guess? This one is the best. You want to take out the greatest common factor, and this is the greatest factor here, the greatest common factor. So you want to take as much out as possible. Alright, if you're confused, don't worry. We're going to explain this all to you. So, what does it mean to remove a common factor? Well, removing a common factor, it's the most basic type of factoring, so we're always going to try that first. When you see a question that says factor, you always should try to take a greatest common factor out first, and I will remind you of that and remind you of that over and over again. It's only possible if all the terms in a polynomial have a common factor. So sometimes you can't do it. Sometimes not all the terms have a common factor to pull out. So maybe before we do anything else, we better talk about what are greatest common factors. Well, we don't have to do too much of that because we already did that earlier in this course, but let's just practice a little bit. What's the greatest common factor of 24 and 30? Now, the way we did it before when we had complicated ones is we made trees, remember? We'd do a tree for 24, 8 and 3, and blah, 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 blah. But I don't think we need to do that here. 24 and 30, all we have to ask is, what's the biggest number that goes into 24 and also goes into 30? Well, 2 goes into both of them, but is there something bigger that goes into both of them? How about 6? 6 goes into both those numbers. I don't think there's anything bigger than that. Here's 3 numbers, 12, 6, and 27. What's the biggest number that goes into all those? 3 is the biggest that goes into all those. Okay, now here's something new, what we haven't done before. Now we have x's and y's and all that kind of stuff. How do you get the greatest common factor here? So there's 2 terms, 14xy and 35x squared. First of all, look at the numbers, 14 and 35. What's the greatest common factor of 14 and 35? 7. The biggest thing you can divide those both by is 7. You can divide 14 by 7, you can divide 35 by 7. Now look at the x's. How many x's do you have on the left side term? 1. How many x's do you have over here? 2. So what's the most x's you can take out of both of those or divide them both by? Only 1, right? You can't divide this one by 2. Oh, you can. You're going to get a negative exponent. You don't want that. The biggest you can take out is 1x. So if it helps you remember, always take the smaller exponent. If you have a 1 here and a 2 there, take the smaller one. And this kind of goes with one of the rules we said before with greatest common factors. Even though it says greatest common factor, you're going to take the smallest exponent. So 1 is smaller than 2, we take x. Okay, now we look at the y's. How many y's do we have here? 1. How many y's do we have here? 0. What's smaller, 1 or 0? 0, so we don't put any y's. Okay, let's try another one. We got 3 terms here. 25, 15, and 60. What's the greatest common factor of 25, 15, and 60? Biggest thing that goes into them? 5. Okay, let's look at the x's. We have 2, we have 6, we have 1 here. Take the smallest amount, 1, so it's x. The y's, 5, 3, and 7. Take the smallest amount, 3. 5xy cubed is the greatest common factor. Do you see, let's just concentrate on the y's here for a second. Do you see why it's y3? Because you could take, there's 5 y's here. 1, 2, 3, 4, 5. There's 3 y's here. 1, 2, 3. And there's 7 here. 1, 2, 3, 4, 5, 6, 7. If we're looking for the biggest amount they have in common, well, the biggest amount they have in common is 3. We can do 3 there, and highlight 3 there, and highlight 3 there. We can't highlight 4 or 5, because this middle one only has 3. So you take the smallest exponent. Okay, now we're ready to start factoring. So this first question, 10x minus 8, we're going to factor that. So how many terms are there here? 2. The first one's 10x, the second one's negative 8. What's the greatest common factor of 10x and 8? Well, if I look at 10 and 8, the biggest thing that goes into both of those is 2. I have 1x here, but I don't have any x here, so that's it. The greatest common factor is 2. Then what I do is I put my bracket, and I ask myself, 2 times what equals 10x? 2 times 5x equals 10x. 2 times what equals negative 8? 2 times negative 4 equals negative 8. We're done. We factored it. If you're not sure whether you have that right, you can check by multiplying. Just go back the way we did previous days. So we could take that answer we got, 2, 5x minus 4. We could expand it, do my mountains. What would you get? 2 times 5x is 10x. 2 times negative 4 is negative 8. 10x minus 8. 10x minus 8. Yep, I have it correct. Just to let you know, the way that most textbooks teach it to you is they tell you to get the greatest common factor out, 2, and then what they tell you to do is divide both of these by 2. 10x divided by 2 is 5x, 8 divided by 2 is 4. You're welcome to do it that way. I've had more success with asking students, what do I multiply 2 by to get 10x? What do I multiply 4 by? What do I multiply 2 by to get negative 8? I'll do it both ways again for the next one, and then I'll probably just stick to this way. Okay, greatest common factor of these 2 terms. There's only 2 terms. Greatest common factor of 6 and 9 is 3. Greatest common factor of m squared and m1. Take the smaller amount, so just m. We have no n's here and 1 n here. Well, we take the smaller amount, which is none. So it's just 3m. That's our greatest common factor. So now you have a choice. You can either do my method, which is 3m times what equals 6m squared. 3m times 2m equals 6m squared. And then 3m times what equals 9mn. We have to make it negative 3, because 3 times negative 3 is negative 9. You already have an m. You only need 1. You only have 1. But you need another n. So you got to put an n in there. Okay, it might, even at first, it might be easier to do it the other method. And again, what the other method is to find that greatest common factor, 3m, and then divide both terms, or all the terms, in this case there's only 2, divide them by 3m. 6m squared divided by 3m, 6 divided by 3 is 2. M squared divided by m to the 1, you subtract the exponents. 2 take away 1 is just 1. 9 divided by 3 is 3 in the second term here, or negative 9 divided by 3 is negative 3, I guess. M divided by m, well, those would cancel, and you're just left with 1n. So whichever method works best for you. I'll just erase this, I don't know why. Okay, next one, greatest common factor, 3 terms this time, so we need the greatest common factor of all of them. Biggest number that goes into 8, 20, and 4? It's 4. Let's look at the y's. We have 4 here, 3 here, 2 here. Smallest amount is 2, so that's our greatest common factor, 4y squared. Okay, what do you have to multiply 4y squared by to get 8y to the 4th? Well, you need to have a 2, 4 times 2 is 8, and you also need 2 more y's, y squared. What do you have to multiply that by to get negative 20y cubed? Well, it needs to be negative 5, 4 times negative 5 is negative 20, you need 1 more y. And then what do you need to multiply 4y squared by to get 4y squared? Now be careful. What do you need to multiply 4y squared by to get 4y squared? You need to multiply 4y squared by 1. You must have plus 1 here. Students often just close the bracket, so they end up having an answer that looks like this. That's completely wrong. If you multiplied this If you did mountains right now, how many terms would you get? You'd multiply this by this and get 8y to the fourth, good. You'd multiply this by the negative 5y and get negative 20y cubed, good. And you'd be done. What about this? Right? You need to have that plus 1 out there. So the rule, if you want, is that the bracket must contain the same number of terms as the unfactored polynomial. So since the original unfactored polynomial had 3 terms, in the bracketed area there must also be 3 terms. 2 terms here must be 2 in the bracket, 2 here, 2 in the bracket, etc., etc. Okay, well, let's move on. 3 terms here, we're looking for the greatest common factor. 12, 15, and 21. Biggest thing that goes into all of those is 3. X squared, x cubed, x fourth. Take the smallest number, which is 2, so x squared. Y cubed, y1, and y squared. Smallest amount is y1. Don't put the 1, just put y. Put your bracket. What do you multiply 3x squared y by to get 12x squared y cubed? Well, you need to multiply the 3 by 4 to get 12. You need to multiply x squared by, oh, we already have x squared. We got the right amount, so we're done there. We need to multiply y. We have 1y here. We need 2 more, so y squared. Okay, what do we multiply 3x squared y by to get negative 15x cubed y? Well, negative 5, because 3 times negative 5 is negative 15. We have 2 x's, we need 3, so we need 1x. We have 1y, and we only need 1y, so we're good there. Third term. What do we multiply 3x squared y by to get 21x4y squared? Well, we need to multiply by 7 to get the 21. 2 x's, but we need 4, so we need 2 more x's. We have 1y, but we need to have 2 actually, so we need another y. Again, if that was too confusing, divide all of these by 3x squared y, 3x squared y, and 3x squared y, and you'll get exactly what I have in the bracket there. Okay, over the page. Now, the point I'm trying to make here is, oftentimes, after you've taken out a greatest common factor, there'll be more factoring to do after that. And in order to make that later factoring easier, another rule for you is, if the first term is negative, include a negative in your GCF. Okay, just if the first one's negative. So that's the case here. Our leading coefficient, the first coefficient, is negative. So when we get our GCF, our greatest common factor, we're going to include negative. You're not really going to understand today why this is important, but when we start doing more factoring, you'll see that it'll leave a nicer amount in the bracket to factor further. So negative. Now look at 30, 10, and 45. What's the greatest common factor there? 5. Look at your n's. 5, 3, and 2. The smallest amount is 2. Look at your p's, 0, 0, and 1, so the smallest is 0. So this is it, negative 5n squared. That's your greatest common factor. Now, what do you multiply that by, negative 5n squared, to get negative 30n to the fifth? Well, you multiply it by positive, don't you? Negative 5 times positive 6 is negative 30. You have 2 n's, you need 5, so n3, you need 3 more. What do you multiply a negative by to get this negative 10n? You have to multiply by positive. Positive 2. Negative 5 times positive 2 is negative 10. You have 2 n's, you need 3, so 1 more n. What do you multiply this negative 5n squared to get positive 45n squared? By a negative. Negative 9, right? Negative 5 times negative 9 is positive 45. 2 n's and you want 2 n's, so that's good. You have no p's, but you actually want a p, so you gotta have that p right there. That's your final answer. Okay, here's one that won't happen very often. It's a bit of a pain. When you have fractions. So you can still have a greatest common factor that's a fraction. Look, they're both quarters. This is 1 quarter. This is 3 quarters. What's the greatest common factor? What's the biggest thing you can take out of each? You can take a quarter out of each of those, can't you? How many quarters are there in 3 quarters? 3. Well, how about the x's? You got 6, you got 7. The smaller amount is 6, so x6. That's your greatest common factor right here. What do you have to multiply that by to get 3 quarters x6? This is 1 quarters x6. We want 3 quarters x6. You just multiply by 3. 1 quarter times 3 is 3 quarters, and that's what you want right there. 6 x's, and that's what you want is 6 x's. 1 quarter times what equals negative 1 quarter? Negative 1. And 6 x's, you want 7, so x. Okay, that answer is okay. We could make it look a little nicer. One thing we could do is put this x to the 6 in the numerator. Since it's just 1 there, we could make it x to the 6 over 4. And the other thing we can do, we don't need that 1 there. We could just have 3 minus x. There's a good answer. Okay, next one. Now, this is a little strange. Your tendency will be to do this. Oh yeah, this is mountains and more mountains here. Don't do that. What do you notice about the parts in brackets? It's the same. X plus 2, x plus 2. If that's the case, you can actually factor out the x plus 2. This is 3 times x plus 2 plus y times x plus 2. You have a greatest common factor of x plus 2. So you're going to factor out the greatest common factor. So the greatest common factor is x plus 2. That comes out front. Now, what do you multiply x plus 2 by to get 3x plus 2? You have to multiply it by 3. What do you have to multiply x plus 2 by to get yx plus 2? You need to multiply it by y. That's it. That's done right there. You'll see these will pop up a lot because there's this other type of factoring which I call Bobby Bridge. I'll explain why some other video. And you'll see it always be like this. The part that's in brackets, the x plus 2, will end up in one bracket. And the other thing, you see how what's left over is 3 plus y, which just goes in the other bracket. Just kind of push those two together. That's always going to happen. Let's try another one. 3m times 2m minus 1, take away 7 times 2m minus 1. Hopefully you notice again, you have the same amount in the brackets. So we can factor out that greatest common factor of 2m minus 1. And then as I said, the part that's out front of each of those will go in the second bracket, 3m minus 7. By the way, back up here, you don't have to do this, but you could change this to x plus 2 and then y plus 3. It's kind of nice. We like to have the variable first, and you're allowed to do that because this is an adding question. Adding, order doesn't matter. Okay, factoring by grouping. So these last two questions here is going to lead up to this factoring by grouping. So this is where you have 4 terms to factor. And you can't always do it, but often you can, so you should look for it to see if you can. Here's the steps for factoring by grouping. First step, group the terms into 2 groups of 2. The way I say it is pair them up. Second step, factor out the GCF in each pair. And the third step, remove the common factor. Okay, you probably need to see this to understand. So here are 4 terms, and there's no greatest common factor for all of them, right? Is there something that goes into all 4 of those terms? Nothing. The greatest common factor is 1. There always is a greatest common factor, but sometimes it's just 1. And when it's 1, it's useless. There's nothing to do. If you divide them all by 1, they all stay the same. So it looks like you can't remove a greatest common factor from all 4. So what we're going to try to do is we're going to try factoring by grouping. So we pair them up. We pair up the first 2. We pair up the second 2. Okay, we're going to look at the first 2 here. What's the GCF of those? GCF of 2n squared and 6n is 2n. Okay, we look at the second 2. What's the GCF of these 2? GCF is 5. And that's it. Alright, so here's what we do. We factor out the GCF in each pair. So in the first pair, we're going to factor out the 2n. And what's left when we factor out 2n? 2n times what equals 2n squared? Well, all we need is another n. 2n times what equals 6n? 3. Okay, good. Now, the next one, the greatest common factor is 5, is positive 5, so we put plus 5. Bracket. What do we have to multiply 5 by to get 5n? You have to multiply it by n. What do you have to multiply 5 by to get 15? You have to multiply it by 3. Now, you'll know you've done it right if what happens? If you end up with the same amount in each bracket. So now you just follow the steps we did in those previous 2 questions. Oh, I've got n plus 3 in both brackets, so I can factor out that n plus 3 as a greatest common factor, and what's left over is 2n plus 5. That's it. We managed to factor those 4 terms. Okay, last one. Let's try the same thing. There's 4 terms. I don't see anything I could take out of all 4 of them. There's no greatest common factor for all 4. So let's pair them up and see if we can take something out of the first 2 and the second 2. Okay, greatest common factor of the first 2. You don't have to write this down. I'm just doing this to make it a little clearer. You could just go right to the answer if you want. Greatest common factor here is 3, goes into 3 and 6, and we got 2 m's and 1 m, so just 1 m is the biggest we can take out. That's an m. For here, be careful. What's the greatest common factor here? This negative is going with the m, so that's a leading coefficient that's negative. Remember what I said back up here. If your first term is negative, include a negative in your GCF. Since my first term here is negative m, my GCF is going to be negative what? What can I divide m by and 2 by? Seems like nothing, but remember what I said? There's always a GCF, 1. So in this case, the GCF is negative 1. If you can't find a GCF, the GCF is 1. Alright, here we go. We're going to put the first GCF, 3m, and ask ourselves, what do we multiply 3m by to get 3m squared? M. What do we multiply 3m by to get 6m? 2. Okay, the next GCF is negative 1. You always, whatever the sign is here, that's the sign that's going to go in this second GCF. So if it was a plus, it'd be plus 1. If it's minus, minus 1. Okay, now you're looking at, what do you multiply negative 1 by to get negative m? You multiply it by m. Negative 1 times m is negative m. Now be very careful here. People all the time when they do this, they end up putting negative 2 here. And then you look and you don't have the same amount in the brackets. You know you must have done something wrong. And that is wrong, because what's negative 1 times negative 2? Right? If this was our mountain right here we were worried about, if we want to check our work, we'd go negative 1 times m, which is negative 1m, or just negative m, good. And negative 1 times negative 2, that's positive 2. We don't want positive 2, we want negative 2. We did something wrong. What did we do wrong? It shouldn't be negative 2 here, it should be positive 2. Negative 1 times positive 2 is negative 2, and it's exactly what we have there. And now look, you have the same amount in each bracket. Take that out as a greatest common factor. M plus 2 is our greatest common factor. What's left over? 3m minus 1. Remember, that's kind of a shortcut I'm giving you there. Really what you're doing is you're asking, what are you multiplying m plus 2 by to get 3m m plus 2? And you're multiplying by 3m. What am I multiplying m plus 2 by to get negative 1 m plus 2? You're multiplying by negative 1. But it's much faster just to look at 3m minus 1. It'll always work like that. Alright, I hope that's making sense. I went especially detailed today, so if I was driving you crazy by going slow, I'm sorry, but I really want to make sure you get this. As I said, this is PreCalc. Alright, enjoy your factoring. I hope you're like me and you learn to love it as I do. Factoring is fun. You and me together.